Moving into a new apartment, you show up, the keys work, the lights turn on. Simple. A Kubernetes pod starting looks calm from the outside too, but underneath, there's a strict sequence of events that can fail in about a dozen different ways before your app ever runs. A Kubernetes pod is the smallest deployable unit in Kubernetes, a wrapper around one or more containers that share the same network and storage. Think of it like a shipping container on a cargo ship. The ship is the node, the cluster is the fleet, and Kubernetes is the logistics company deciding what goes where and when. Each pod gets its own internal IP address, its own little slice of resources, and a defined life cycle, from the moment it's scheduled to the moment it terminates. That life cycle has specific phases, and each phase matters. Most Kubernetes problems, crashes, failed deployments, services that won't start, trace back to something going wrong during pod startup. A team pushes a new release on a Friday afternoon. The deployment goes out, pods show as running in the dashboard, but requests are failing. Why? Because running doesn't mean ready. The app inside the container might still be initializing, a database connection might not be established, or a startup probe might not be configured correctly. Understanding the pod lifecycle means you can diagnose that in 3 minutes instead of 3 hours. This is the difference between knowing how to use Kubernetes and actually understanding it. When a pod gets created, the first thing that happens is scheduling. The Kubernetes scheduler looks at available nodes, the physical or virtual machines in your cluster, and picks one based on resource availability and constraints like node selectors or taints. Once a node is chosen, the kubelet takes over. The kubelet is the agent running on every node, and it's responsible for actually making the pod happen. The kubelet pulls the pod spec and starts working through it in order. First come init containers. These run sequentially, one at a time, each must complete successfully before the next starts, and they all finish before your main application container ever launches. They're designed for setup tasks, waiting for a database to be reachable, loading configuration from a secret store, seeding a cache. If an init container fails, the pod restarts from that point. That's often where a crash loop backoff error begins. Once init containers finish, the main containers start. The kubelet pulls the container image if it's not already cached on the node, and if that image doesn't exist or the registry credentials are wrong, you get an image pullback off error right here. After the container starts, Kubernetes runs your probes. A startup probe checks whether the application is finished initializing. A readiness probe checks whether it's ready to accept traffic. A liveness probe checks whether it's still alive and should keep running. These are independent checks, and if you only configure a liveness probe and skip the startup probe, Kubernetes might kill a slow starting container before it ever gets a chance to run. And if this kind of mechanism level detail is what you want to understand, Stack Future covers one concept like this every day. The pod moves through phases, pending while it's being scheduled and images are being pulled. Running once, at least one container is active and then either succeeded or failed depending on how it exits. Say you're deploying a Spring Boot service to a Kubernetes cluster. The app typically takes about 45 seconds to fully start. You've got a liveness probe configured with an initial delay of 20 seconds and a failure threshold of 3 checks at 10-second intervals. That means Kubernetes starts checking at 20 seconds, and by 50 seconds, it's already failed 3 checks and killed the container, before your app ever finished starting. The pod enters crash loop back off. In your logs, you see connection refused on the health endpoint. Looks like an app bug, it's not. The fix is a startup probe. In your pod spec, under the container definition, you add a startup probe with a higher failure threshold, say 30, and a period seconds of 5. That gives the app up to 150 seconds to pass its first health check before the liveness probe ever activates. One configuration block. Deployment succeeds. That's not a workaround. That's the feature working as designed. A Kubernetes pod starting is not a single event. It's a sequence. Scheduling, init containers, image pulling, container startup, and probe evaluation, each one a potential failure point. Know that sequence and you can read almost any pod error and know exactly where to look. If you want to go deeper, understanding how Kubernetes handles pod restarts and back-off timing is a natural next step. If this helped, the like button is right there. It genuinely helps this channel reach more people.